Hey everyone, and welcome back to the GCSE Maths series. Today we're going to be looking at scatter graphs. So, what is a scatter graph? A scatter graph is a visual display of a relationship between two variables slash factors. So, it is a graph which displays how each event or each factor affects the other one, and we look at the correlation between both of them. So, in this example here, our two factors are maths mark and English mark, and this is obviously to do with students taking a test. And what we can see here is that on the bottom axis, we are plotting the student's maths mark, and on the y-axis, we're plotting our English mark. And we plot, so each one of these represents a student, and as you can see here, his maths mark was somewhere was looks like maths mark was equal to 28, and his English mark was equal to about 88, right? So a scatter graph can help us determine the relationship between how a student did in their English compared to their maths, and seeing if there's any correlation between people who are good at English, people who are good at maths. Are they both good at English and maths and just academically superb, or are they good at English and not good at maths? And is there some, it's just working out a relationship between two variables, as we said in the definition. So here, this blue line, as you can see here, is called our line of best fit. And this is just a line drawn between trying to cover as many points in the graph. So as you can see, the line has been drawn in the middle of where the points have been plotted. So it's supposed to give the most accurate representation of the data in terms of a straight line. So obviously you can see that some vary, some go off the line quite a lot, some go here and here, but this is the best average that the student found, or whoever plotted this graph found, and plotted that line with a ruler, and just drew through as many lines, as many points as possible. So okay, so now looking at the two different types of correlation, as seen plotted on these graphs, we can call this one our positive correlation, and call this one our negative correlation. So if we were to, let me just make factors up on the spot actually. So let's just say this one is yearly income in pounds, and let's say value of a of car in pounds. As you can see, as the yearly incomes increase of these people, it tends to show that their value of the car that they drive also increases. So obviously the value of the car is measured this way, and the yearly incomes goes up this way. As you can see, it's sort of edged toward that top right corner, showing as yearly incomes increase, the value of the car they drive also increases, or tends to increase. Hence, we can draw our positive correlation line, our line of best fit, something like this. And obviously, it doesn't have to be perfect, but it just kind of has to represent the most accurate representation of the data. So a positive straight line like that. So now looking at negative correlation, a negative correlation means that as one variable increases, the other decreases. So they don't act in the same way. As you saw in positive, as one increased, the other also increased. And negative is saying as one variable increases, the other decreases, right? So let's say, for as an example, obviously you know that the graphs increase, or decrease, sorry, going down that way, and decrease going down that way. Okay, let me just oh, let me just clean this up. And let's create an example off the top of our head and say, okay, as hours of the exercise per week increase, so hours of exercise, body fat percentage decreases. And as you can see, that as our body fat decreases going down towards zero, and our hours of exercise increase, it shows a negative correlation. So as the hours of exercise increase, oh, doesn't look great, does it? And so body fat body fat tends to decrease, showing a negative correlation there. Okay, we can use these graphs to we can use these graphs that we have to estimate data in our set, or outside of our set, sorry. So let's start with linear extrapolation. Now, this basically means we have our data and it has been plotted in our scatter graph, as you can see. We now want to predict something that is not within our data set. Say this is, going back to our example here, yearly incomes. Let's say this ends at 100,000 and value of a car also ends at 100,000. Okay, and now if our question then said predict the value of someone's car that earns 120,000, well, we can't really do that because it's not in our data set. But what we can do is extend my very bent line. It should be straighter like that, and then extend our graph and say, okay, 120,000 is here. Let me now see what it will be worth, and extend your scales like this, and then you can see by extrapolating. Remember, extra in extrapolation stands for extra, like extracurricular, outside of your curriculum, outside of the data set, outside of what has been plotted. What would you be able to do? What would you be able to predict? So in this case, what would we would just, we'll draw this line and then draw the line back down to the value of the car to see exactly where to how much it'd be worth. Okay, moving on to the next type of estimation. It's called linear interpolation. It is a method of estimating an unknown value between known values on a straight line. So we can have our correlation graph, our scatter graph, like so, and say, okay, so we have our line of best fit like this, and say there is a value in this set, in this data that we've plotted, which, okay, it falls in between the data sets. So say this goes from 100 to 100,000, like we said before, and obviously this is going to be 100,000 here. Say we wanted to find out someone's value of 63,000 as the value of their car, right? And we wanted to see how much would you predict they earn. Okay, using this model that we have in our graph, we can then draw 63,000 here. And also, I forgot to mention, imagine these points go up in 10,000. So 63,000 will not be plotted as a point on this graph. So there's no way of actually estimating how much it will be worth. We draw our line up here to our line of best fit, draw it across, and that looks about 70,000. Okay, so then we can say we would expect them to earn £70,000 per year. Okay, that's going to conclude today's revision lesson. I hope you guys enjoyed. As always, please make sure to like, comment, and subscribe, and I'll catch you guys in the next one. Peace.